Good evening, everyone. Just doing a quick mic check, if someone could kindly confirm. All right. So I'll just get started. So I'd like to thank you, everyone, for joining us in today's evening. Today, we're going to be exploring the career paths in data and what are some of the aspects of the data jobs that are out there and how you can reach them. So today we're going to be mainly focusing on data analytics, data science, and data engineering. We'll also be talking about what a career in data entails and doing a comparison of these careers to look at the difference in responsibilities, skills, and tools used, as well as talk about what a typical workday may look like. We'll also share some tips and resources on how you can get started with a career in data. So first off, I'd like to introduce myself. My name is Adnan, and I'm the program manager of the Applied Business Intelligence program at WeCloudData. My role also involves in working with the faculty and operations team to ensure a deep and smooth learning experience for BI students, from individually getting to know each of the students and guiding their progress throughout the bootcamp to ensuring they are receiving the best of support from our faculty. I previously have a double degree in software engineering, and I've worked in multiple engineering and analytical roles in different industries. Today, I'm joined by Eric. If you could kindly introduce yourself.
Yes, thanks, Adan. My name's Eric. I'm the data engineer program manager. Before joining WeCloudData, I'm a data engineer in Newson, and also worked as consultant for system and program manager and so on. Thank you.
Thank you, Eric. So before we jump into it, I'd like to mention if you have a question, please either raise your hand by clicking on reactions and then raise hand, or you could just type it directly into the chat box. For mobile users, if you click on more, it should give you that option as well, and we'll be happy to answer any questions you have. Before we go into possible careers in data, I'd like us to take a moment and see what data is about and how it has played a role in our life. To loosely define data, we could say that data is information that has been collected for reference or analysis. It can take on multiple forms, such as in images, audio, text, measurements, etc. And the analysis of it allows us to discover interesting insights and/or make informed decisions. Data is actually very prevalent in many aspects of our daily lives, and in ways you may have not even realized. As such, it has become very crucial for businesses and organizations throughout the world in the digital age to leverage the information in that data. For example, when you go on the internet, have you ever felt like it just knew what you were looking for? Maybe you were thinking about something, or you may have searched about something, and suddenly in a very unrelated website, you would have seen an ad for it pop up. Or maybe when you're on Amazon, maybe you may have been looking for Thanksgiving dinner preparation, like maybe a turkey baster, and suddenly it gives you a bunch of other recommendations like thermometers or like oven mitts and things like that, right? The reason why that is happening is because the information that is being collected about you throughout your interaction with the site is being recorded and collected so that your experience in a specific site can be personalized. Things like what demographic do you fall under, or what kind of content do you interact with, and how often do you interact with it. Knowing this info, amongst other things, like even the type of device you use or what times you visit the page, these sites and these organizations can make predictions about your behavior and preferences. We could also compare your info to other users and use the aggregated data to suggest posts, ads, or search terms based on your preference in relation to similar users. If you're interested in learning more about this is actually called collaborative filtering, and applications like TikTok, Instagram, Netflix, Spotify, and etc. use this to help recommend things that might be interesting to you. Data is also used in healthcare and medical services. For example, tracking health information and patterns in private databases, predicting diseases, apps that make personal health recommendations, and etc. There's a lot of data to be found from consumers as well. When you go shopping online, info about you and your habits are being collected so that the site can suggest products specific to you, as I mentioned before for the Amazon example. Data about the interest in certain products can be used to decide on how to stock inventory or make other business decisions. With these processes, businesses are able to provide you their products and services at a better value than before, instead of flooding you with irrelevant products that you may not care for. While profit is the primary goal for most businesses, all businesses realize that their main focus should be to acquire and retain customers with relevant business offerings that keeps them coming back. With increasing competition in the market for any type of product, it becomes even more essential for businesses to understand their customers better and optimize their offerings accordingly, or risk being overshadowed by more digitally enabled competitors. Here are some of more applications of data. It is now commonplace knowledge that retailers are micro-inspecting customer purchase history, telecommunications industry tracking the voice and data usage of customers, airlines logging every flight path, schedule, and customer feedback, and a never-ending list of how data has become one of the most valuable assets of a business. Some of the typical use cases that data is employed in are customer relationship management, process optimization, network optimization, product improvement, budget control, and marketing optimization, amongst countless others. You could almost think of it as anything that was manually being done before, and now that with the digital age, there's a way to collect more information and more data about it. Data analytics or data science is somehow being used on all that data to basically improve that process or improve the aspect of that process that the data is being collected about. Now, there are many, many different use cases for data, and with the amount of it growing exponentially everywhere, careers in data definitely make for a stable one. With the advent of the digital age, every digital interaction and piece of data recorded can offer a huge deal of insightful information and statistical power. By 2025, it has been estimated that the cyber world value will reach around $280 billion, consisting of 175 zettabytes. For a quick reference, 1 zettabyte is equal to 1 trillion gigabytes. So this estimated capacity value would be around 175 trillion gigabytes of data. So you can imagine how big that is. With this staggering volume of data, organizations are starting to increasingly rely on data initiatives in order to tap into this digital age goldmine. Tech companies like Facebook, LinkedIn, Twitter, Google, and others have already made data their primary product, and more companies are starting to follow suit. As they say, information is power, we are seeing it being practiced in the business world increasingly. So I see that we have a few questions before I move on. So halfway through Google Analytics, what is the best way to land a job as junior data analyst with no experience? Well, that is something that we're also going to touch upon later, but to put it in a just, even if you don't have the experience that most companies ask for, in IT or in the technology world, there is a loophole where you can work against that. So even if you don't have the experience, if you're able to prove it to the potential employers that you have the required expertise, regardless of how long you've spent in it, then they would be more than happy to hire you. I'm pretty sure you've seen posts on LinkedIn and other social media pages where there's a lot of talk about Google and all these large companies not really caring if you have a proper background in tech. As long as you're able to code and as long as you're able to solve business problems, they would be more than willing to hire you over candidates who might have the educational background requirement, but they might not be able to solve a simple hacker rank question or a lead code question. So even if you don't have the experience, your portfolio and the skills that you show and the work that you've done that you show to the potential employer, it can definitely be a more convincing factor than just stating on your resume that I have worked X number of years in this company. While working an X number of years definitely shows that yes, they have been vouched for by another company, that is not the only way to get hired in tech. I hope that answers the question. All right, perfect. Okay, so let's take a look at the data value gap that is being generated. Now that we know that the capacity of the data cyber world is consistently increasing and exponentially actually increasing, let's take a look at what the data value gap means. After COVID-19, the businesses that had relied on more traditional methods of operation have been coerced into adopting digital processes in order to continue operating in the rough economic and regulatory conditions of the pandemic. One thing to note, though, is that even though companies are generating so much data, there seems to always be a shortage of accessible and valuable information. According to a Forrester report in 2019, between 60% and 73% of all data within an enterprise goes unused for analytics. At an age where deeper and actionable insights, especially about customers, are an absolute competitive necessity, there's a real need for companies to step up their data-driven initiatives. Even though many companies are now fully aware of that after the pandemic-induced digital transformation race amongst all the industries, the main obstacle for a company to become more data resilient is due to the lack of sufficient data skills that hinder such initiatives. There's a real shortage of tech workers in the industry, which is driving up the demand and pay scales of these skilled roles. Adding to that is the ever-present lack of sufficient data skills amongst current employees, and even actually amongst industry leaders that would allow businesses to rely on more analytical ventures using the data already retained by the businesses. So now that we know we have an overview of how important crucial data is in the business world, let's dive into what are some of the career pathways that you could be involved in data. As data by itself is unprocessed and messy, it has to be processed properly with relevant business context to arrive at the required answer. The idea of using data is to be able to channel from multiple sources of raw data to arrive at a unified answer to business problems. To that extent, a business requires different types of talent that are able to support the process, from collecting relevant data, processing the structure of the data to better fit the business needs, and apply the different data processing techniques to arrive at the final answer. Let's take a look at what are some of the core competencies that are required to be able to navigate the complexities of the data landscape. In this presentation, the ones we'll be focusing on are data science, business intelligence, data engineering, and machine learning engineering. Here's a short Venn diagram to help you visualize the relationship between each of the fields pictured here. So we first start off with computer science. Computer science is the programming knowledge that you will need when working with various data structures and algorithms, data preprocessing and validation, etc. Some examples of languages you may need to know include SQL, Python, R or SAS, and a multitude of others that are out there. Even though you will not be needing the expertise in computer science of a software engineer who purely focuses on programming, a certain degree of programming proficiency is required to interface with digital systems to process the data. The next one over, we have math and statistics. Some key concepts would be probability theory or distribution, understanding statistical significance, hypothesis testing, regression analysis, etc. Data professionals who are looking to delve into business insights would have to use mathematical processes to prove the correlation or hypothesis that they're putting forward. In the end of the day, digital data is a bunch of zeros and ones. So being able to use different mathematical functions on data is what allows it to be so valuable and insightful. For example, the probability theory plays a key role in predictive analytics. To put it simply, probability, when you consider it in its basis, it simply means the likelihood of an event to occur and always takes a value of either yes or no, or 0 and 1. If you were to find out the probability of an event occurring, you could use historical data to build a model as to whether the future event outcome would be a 0 or a 1. And many different mathematical other models similar to this are used to process data to better explain current events or predict future predictions. So I see that we have a few messages in the chat. Okay, I heard that Python is not as used much anymore. I am not too sure we've heard that, because according to my knowledge, Python is actually increasingly being used, and it's actually replacing R in certain cases because of the type of library support that Python has. Python is a general purpose programming language, and with the open source nature that it actually has a very huge community supporting it. So every day you'll see some sort of new library that is being released to the market. And each of these libraries basically help you do certain tasks much quicker than before. And if you think about it, a lot of the artificial intelligence and machine learning algorithms are actually implemented in Python as well. There are definitely other softwares that do that, but Python is also one of the top softwares that do that. So I have noticed many companies ask for R. R is actually one of the earlier tools that was adopted for data science. So when it comes to talent, there are more people that know R for data analysis than for Python. But I think that number is very similar now. It'd be hard to say. Yes, Katrina, that actually is correct. Python is definitely used more for building ML and AI applications. And if you're just working with statistics, just pure statistics, R would definitely be a relevant option. Okay, so jumping back, lastly, we have domain expertise, which is having a good understanding of your data. That is, knowing how the business model works, what the future outlook may look like, keeping up with current trends, knowing the industry influences and stakeholders, and domain knowledge. As we are trying to use data to better understand and improve different business aspects, it is more important for a data professional to have a clear understanding of the business model itself and what the business goals the data should and could be catered towards. Asking the right questions is typically what is the starting point of any analytical process, and having a sound business acumen allows you to differentiate between what is important to the business and what is not. Another great skill to have in this section would be to be able to explain technical concepts using terminology everyone can easily understand, allowing for better communication. As data insights is needed by different functional business departments, it is imperative that a data professional is able to convey technical jargon to all types of audiences. Conversely, a data professional has also be able to communicate with business stakeholders to understand what are the requirements that the data needs to be able to fulfill. As you can see, these data roles intersect with different domains. Data science in particular would be considered as the intersection between all of them, meaning that you would need to be proficient in statistics, math, business acumen, domain expertise, and programming. Data engineering would rely more on the domain expertise, computer science, machine learning, computer science, and math and statistics. Business intelligence maybe between math and statistics and domain expertise. However, please keep in mind that there are many other careers in data that exist out there. And this is just to help you get an idea of what you need to know for certain types of jobs like these. And I'll talk a bit about other data careers in the next slide. So here are some examples of other careers in data that I'll go through briefly. A data architect is someone who designs and manages data systems, sets policies for how data is stored and accessed, and often liaises with other data teams, such as data engineers, data scientists, data analysts, data management, data security, countless others. Typically, data architects have many years of experience with data modeling, data design, and data management. As they're responsible for designing the data infrastructure of the business unit or the organization, they are actually highly lucrative jobs that are in high demand in this data-driven age. Data architects are usually considered senior positions, but if you already have some expertise with data, then you could always definitely work towards that. A database manager or database administrator is someone who monitors and optimizes database performance. Other responsibilities may include supervising the development team, backing up the data, and developing restoration controls, probably helping build the structure and design of the database, as well as enhancing its scalability. As the business grows, so does the complexity of the databases that store all the business data. With increasing data, it is very important, and it's actually very cost sensitive as well, to be able to optimize these databases in order to ensure timely delivery of data and also reduce operational costs. They may also coordinate with the IT specialists to ensure data security. And this is where a data security analyst would come in. Data security analysts create security policies and procedures, make recommendations for improvements in the data security systems, and perform security audits to check for breaches. This role usually requires knowledge of security management frameworks, network infrastructure, data privacy, and regulations, amongst others. As the value of data becomes more apparent through the use of analytics, both internal and external threats have to be considered carefully. It is also a core responsibility of a business to be able to protect the data of the customers that they have been entrusted with, as well as prevent vital business information from being leaked. Although this by no means is an extensive list, the last one I'd like to mention is a research analyst. Research analysts are actually experts in their respective fields, for example, finance, healthcare, tech, gaming, and they're mainly responsible for using the data skills that they have in order to analyze, interpret, and prepare reports out of the company data for stakeholder use. So let's take a quick look at what a typical data team consists of. Now, just to mention, this is not all that a data team can consist of, but this is generally what a typical data team would consist of. By having these four roles, data scientists, data engineers, data analysts, and machine learning engineers collaborate with each other, this allows them to focus on their own specific skill sets and operate like a well-oiled machine. So first off, you have the data scientists. They are generally responsible for building machine learning pipelines and use the results to guide business decision-making. Machine learning engineers would train and tune advanced artificial intelligence or machine learning models to be put into production via model pipelines, registry, packaging, deployment, and monitoring in a scalable way. Data engineers, on the other hand, build data pipelines and data models to supply data for BI and DS usage. And business intelligence or data analysts help businesses make informed decisions and understand the what or why via data analysis and visual storytelling. Now that we have an understanding of how data teams are structured, let's explore how different roles fit into the data maturity of a company. Different companies are at different stages of their data maturity. Some companies may only have a few Excel tables or a few Excel spreadsheets of data, while others may collect terabytes of data daily from their business operations. To that end, some companies may require reporting specialists to handle all their business needs, while the other more data-driven organizations, like the larger ones like Facebook or Google, they would require multiple data teams that handle a variety of data silos that could be catered towards different business unit. So for example, within one team, like let's say the finance department, they could have tens of different data teams, each catered towards a specific role or a specific use case. For example, in a small retail store, their data maturity might be limited to tracking their inventory, sales, and employee timesheet on Excel, and would probably require the expertise of a reporting specialist. Since their data would span no more than a few hundred megabytes, almost all of the tasks can be carried out in Excel and would not require any more expertise. In contrast, imagine a large telecom company that requires to handle a few billion calls per day. Their data systems would have to be supported by a dedicated data team or multiple dedicated data teams in order to handle that magnitude of data continuously flowing into their data silos. Since that data is also used to track performance metrics and feed other automated systems, an ensemble of data engineers, data scientists, machine learning engineers, and business intelligence analysts would be required to work together for a specific department of the company. What we're looking at here is the variety of options that are available to data professionals. If you are new to the data field and are looking for an initial stepping stone, companies with lower data maturity would have less demanding roles, but also may not be able to provide enough opportunity to learn from your peers and boost your personal growth. On the other hand, joining a data mature company as a new entrant to the field can be kind of demanding, but can also lead to high risk rewards, as you are able to draw from the experience of your peers and fast track your career much quicker. As a seasoned data professional, your opportunities would be ample in companies with higher investment in their data teams, which means you could be looking for lucrative opportunities very easily, and also work with dedicated teams that form the core functional departments of a business. As data or information becomes more imperative to the company, so does your value as a data professional who is able to incorporate the value derived from data into the daily business operations. So in this slide, let's take a quick comparison between the different job titles, the skills needed, and the tools used between each career. So let's start off with data engineering. Data engineers are mainly responsible for building and maintaining pipelines through which data flows around in different locations of a business. From building ingestion channels from raw data sources to supplying process data to data scientists and business intelligence professionals, you can consider them to be the engineers that maintain the bridges and roadways to keep the data traffic flowing smoothly and efficiently in a company. With the explosive growth of data in the cyber world, and being able to manage such a magnitude of data requires a very specific set of skills that allows companies to work with data at scale. As with planning roads and bridges, the data traffic can vary over different periods of time and has to be accounted for by data engineers so that the data pipelines do not fail and are also operating at an optimal level without allowing for too much free broad bandwidth. Some of the possible jobs for data engineers are, but not limited to, data engineers, data warehouse specialists, data architects, big data developers, or engineers. Since it is a role which deals with technical aspects of data, data engineering is also highly focused on technical skills that are used to build and maintain the infrastructure of data pipelines. Coding skills such as Python, Scala, as well as containerization skills, always have a problem with that word, are highly necessary for developing these pipelines, in addition to being proficient in big data and cloud technologies. In the next one we have is data scientists, a well-rounded role that requires both technical and communication skills. It involves the ability to process data, derive insights, and visualize it, and communicate it to stakeholders. If we're considering data engineers as the engineers who build the roads for data, data scientists are basically responsible to use statistics to understand the flow of data and analyze if there is any significant relationship between different data and predict where that data could lead to. As data continues to grow and become more accessible, the demand for data scientists also grow along with it. And in fact, being able to work with big data is also becoming a part of data scientist's skill set. In addition to the title of a data scientist, you may also see some other related ones in this field, like analytics consultant, machine learning scientist or researcher, or even statistician. Overall, the main skills and tools needed would be exercising analytical and critical thinking and coding, which is basically the languages you need to know, such as Python and R, but they generally vary amongst the companies. But generally, Python and R, SQL are one of the top languages that you should know. You'll also need to know some machine learning and be able to go through various steps of data collection, data preparation, so that you're basically making the data analysis ready by cleaning it, training your model, and evaluating it. And of course, further improving your model by tuning the parameters. For machine learning engineering, this role involves training and tuning advanced machine learning algorithms, and then packaging them for production in a scalable manner. It also involves machine learning operations, which practices better communication between the technical team and operations professionals, and reliable deployment of those models built in large-scale production environments. Machine learning engineers are required to teach computers to predict where the data flows based on historical data, if we're still considering the metaphor where we're saying that data engineers are the engineers who maintain the road and data scientists predict where that data flows. machine learning engineering roles or machine learning, it's suitable for data scientists or data engineers or software engineers who are interested in machine learning model deployment in production, or anyone with prior experience with machine learning, data science, and also has strong programming skills. Some of the tools that are used are coding, such as Python and Java, and you'll also have to be able to work with machine learning at scale, such as Spark for large-scale data processing, Docker for containerization, continuous integration and development and deployment of application, which is sometimes referred to as CI/CD, and cloud technologies such as AWS, Google Cloud Program, or Azure. As you can tell, this role does have some skills and responsibilities that overlap with data science, but overall demands for more understanding of advanced machine learning algorithms and deployment in production. Finally, we have the business intelligence or data analytics. So this role involves using the business data to build analytical dashboards and reports that cater to different business units. They work closely with different stakeholders to understand the business questions and answer them through analytical reports and visualizations. They also work closely with data engineers, machine learning engineers, and data scientists to understand what process data to use and also convey the requirements needed to reach the answers in terms of data availability and accuracy. Business intelligence or data analytics is usually considered to be an entry point into the data world for companies with low data maturity, as well as individuals who do not have experience with data. As the need for data literate professionals booms in the industry, professionals who are looking to enhance their work productivity and accuracy find BI an appropriate entryway to combine their existing business knowledge with data skills. As the data maturity of a company commences and grows, BI professionals are required from the early stages of data reporting to building AI-powered analytical dashboards. Along with data literacy, some of the vital skills that are required by a business intelligence or data analyst professional would be the ability to source, clean, and model data in companies that are early in their stages of data maturity, to supporting strategic business decisions made by executives with contextual visualization and self-service dashboards. Along with SQL being a core competency for any BI professional, they would also have to use the visualization tools like Tableau, SQL, Power BI, and a myriad of other visualization and dashboards and softwares. If you are surprised at why Excel is also included in this list, it is honestly still one of the most popular tools that are used for analytics in companies that are in their early stages of data maturity. As the Microsoft Office or the Microsoft business tools have become an irreplaceable vendor for most businesses in the business world, many companies still use the feature-rich capabilities of Excel to process and understand data at a smaller scale. So in this slide, let's take a look at what are some of the prospective benefits that you could get, or the work environments that you could have with each of these roles. For data engineers, as the data engineering role are more focused towards a very niche skill set, the salary scale also reflects the importance and demand of these roles. As more companies rely on digital technologies, there's an explosive growth in data engineering jobs nowadays, especially during and after the pandemic. The average salaries that are usually on the, sorry, there's a bunch of marks on there. Okay. So the general salary scale that starts off for data engineers can be an average of around $90,000 and can go as high as up to $116,000 or even $140,000 for senior positions. For the work environment, or the typical work environment for a typical data engineer, is generally confined within the team, but data engineers can also perform their jobs on-site or remotely, depending on the nature of the company. Moving on to data science, their typical work environment involves collaborating with other data departments, but also has its individual share of work. The average base salary starts off at around 83,000, which is slightly lower than data engineering. That is because data engineering is recent. It's much more recent compared to data science. But even then, the senior positions can go up to $110,000, and that is the numbers in Canada. If you were to compare it to the US numbers or the US salary scales, it would be much higher. There are reports of companies like Netflix and Facebook paying up to $500,000, $500,000, $300,000 easily for data science and data engineering roles. Machine learning engineers are usually considered a part of the data science team, but they'll also work with other data teams to deploy and maintain the data product. Entry positions usually start around $91,000, but it can range as high up to $118,000 for intermediate positions. Now that we consider that machine learning engineers are relatively new, or the role itself is relatively new to the market, there's not enough data collected on senior positions, but it could easily match data science senior positions, which would be up to $200,000. As for BI positions, they span generally from entry-level reporting positions to senior-level BI developers. And it honestly depends on the company and role that you're looking for. Entry-level positions in Toronto, at least, start around $55,000 for reporting specialists in low data maturity companies, while high data maturity companies pay around $65,000 to $70,000 for junior positions. Once you climb up the ranks, it can definitely go up to above 90,000. And if you're able to reach the position of data business intelligence manager or business intelligence director, then it can easily range up to 110,000 plus. Since it's inevitable that all companies will have to rely on digital technologies in order to compete effectively, BI roles are prevalent throughout all types of industries and functional departments. To that end, the job outlook will only keep on increasing as more companies move away from traditional and analog processes to digital platforms. Okay, so now I'm going to pass it over to Eric, and he will be talking a bit about what a typical workday looks like for each of these roles.
Thank you, Anand. So can you jump to the next page? Yeah, thank you. So let's talk about the different roles in data fields. So actually, data fields, although there are several roles, but it's very common, different roles work together in a group. But it doesn't mean, all these roles work in one team because, different company have different requirements. So let's say, but usually your data engineer will be the foundation of each different team. So no matter what kind of requirements for the data team, data engineer will be there. So let's talk about data engineer. Let's say here is a very traditional data team. So their company, their data source very simple. They get their data from their operational system, and they want to do some data analysis, or maybe their data very the size are very big. Maybe they want to do some data analysis in data warehouse. So usually, for this team, there's a combination of a data engineer and the data analyst or BI. So first of all, data engineer they will write scripts to get data from their operational system, and when the data dump into some place, either data lake or a data warehouse, they will write some scripts to transform data, to clean the data, and process data, and make the data available for data analyst. Okay, and when the data is ready for data analysis, the data analysis, here you see there's the BI or data analysis. This is a different, although it's very similar, but it's a different roles. For data analyst, usually the most important thing, the most important tool they are using is to write SQL. Okay, they work in the data database to write a query to generate reports. But when the company using some BI tools, let's say Power BI and so on, and there will be a requirements for BI developer. Okay, so BI developer mostly work in BI tool. Let's say they work in um, Power BI, and they use some functionality or use some let's say use DAX, DAX queries and so on to build some reports. Okay, so you can see we are, they are going to build some reports and dashboards. Okay, so this is a traditional team, but recently there was a trend that's, that's the company gets more and more big, and their data size get more and more big. So they are considering if I can use this data for prediction. So that's why there is another role come, which is data scientist. Okay, so comparing the data scientist and data analysis. The data analysis is mostly based on the history to build some reports to generate some insight for the previous period. Okay, but data scientists, they based on the data and generate some reports maybe to predict the future. And so for data scientists, they mostly use Python, or although they can use R or even use Java, and some other coding tools, but Python is the most popular tool. Okay, so they use Python to, first of all, they need Python to create some table they want, and then they built a machine learning model, and they put this machine learning model on this data to train the model to build some prediction and to evaluate this data and to check whether evaluate this model to check what to see whether this model is the appropriate model for this business, and then they will do several rounds of training and several rounds of testing and so on, and finally gets this model. So, and in this way, they can use this model to predict for the prediction functions or for some classification purpose. So, but this is mostly is on batch. Let's say a bank. Okay, so they try to predict whether this they are going to do a promotion, and whether which customer they need to send their email, so they can use this model to give a list of so which customer is the best customer for them to send this promotion email. And this for the data scientists, mostly they work in this way. But what about let's say we are using YouTube. Okay, so YouTube have function to predict your behavior, right? So when you watch this type of videos more, will give you more this type of videos, right? So in this way, they use this kind of machine learning model in a higher level requirements. So that's why it come, machine learning engineer. So machine learning engineer usually, they get the data model from the data scientist, okay, and they deploy this model into a live online system. So what they are going to do daily is, they get the model and they build the system infrastructure and deploy the model in cloud and test this model, and in their let's say development system, and then deploy that into their production system. So this will mostly be the machine learning engineers work. So for machine learning engineer, they have more coding backgrounds. So usually for machine learning engineer, they switch from software engineer and they know some knowledge of machine learning, and then they become a machine learning engineer. So that's mostly the different roles of their daily work. So is there any questions about this? Okay, cool. So what mostly this is the most common roles in the data team. Of course, we have another roles we did not mention here is data architect. So data architect is the I would say the framework of the data team. So they will decide how to build this data platform, and let's say what kind of when they use a data warehouse, what size of a data warehouse it will look like, and they will predict the trend of their data growing, and decide so how big data warehouse we can use, and they will predict the future requirements, what kind of functionality we need to keep. Although in current project maybe we don't need them. Okay, so that's mostly the daily work for the different data roles. Okay, thank you, Adnan. Okay, among these roles, let me answer this question. Among these roles, the data scientists require most mathematics skills. Yes, but it depends on what kind of data scientist you are in. Let's say, because data scientists, they can be operational data scientists or research data scientist. Let's say we WeCloudData, we have several graduates from data science bootcamp. Okay, so they are mostly operational data scientists, which means they use the existing model. They tune this type of model. Okay, and they use this model for a real business scenario. That's operational data scientist. But for the research data scientist, you must have a PhD. I know several PhD in data science in the data science field. Okay, so their work is to use the mathematical way to build a brand new data model. This data model, previously maybe let's say for some business scenario, previously there is no very proper data model for this business scenario. But for this data research data scientist, they will build a data model with their machine learning, with their mathematics knowledge to build such model for this business scenario. And this model will be used, maybe will be published on internet or for everybody in the world, and they can download this model and to use this for others. So many PhD, they work like this. So it's not necessary to say we must have a very good background of mathematics so that we can be a data scientist. It's not that way. So, and if for the operational data scientist, of course you need to know some mathematics, but it's not too much. Okay.
Okay, thank you very much, Eric. If anyone has any other questions, please feel free to leave it in the chat, okay? All right, so now that we have taken a look at what are some of the careers in data and what the typical workday of data looks like, let's talk a bit about if you should pursue a career in data and what makes it a good field to go into. So after the COVID-19 pandemic overtook the world, it heavily impacted our daily lives in many different ways, but also how businesses performed across the world. As you may know, within the initial months of the pandemic, the world went through a flurry of lockdowns that spurred panic buying and brought vital business operations to a complete halt. The supply chain industry was also crippled due to the panic buying to an extent where store shelves remained empty for days due to the logistical industry and being unable to cope up with the sudden change in demand. And in addition, of course, to the regional COVID restrictions that shut down production facilities and supply chains. As businesses were facing an unprecedented situation where no external information seemed too reliable, business leaders started turning their focus on their own data, on their own business data to better manage risks, fuel decision making, and provide valuable insights into developing strategy. With no end to the pandemic in sight and a very altered business operation landscape, businesses had to shift their strategies that they had been following for a very long time to adapt to the new norms of digital remote operations and sales channels through rapid digital transformation. According to a McKinsey global survey of executives of around 900 C-level executives and senior managers, their companies have increased funding for digital initiatives more than anything else in the company, be it cost increase, number of people in technology roles, and even the number of customers. As the pandemic progressed, consumers have increasingly shifted towards digital sales channels, and businesses have reacted appropriately. In this survey result from McKinsey, you can see that the global adoption of digital channels have actually accelerated by 3 to 4 years on average, where respondents to the survey were at least 3 times likelier to say that at least 80% of their customer interactions are actually now digital in nature. So companies like Walmart or Home Depot or all these big box retailers that we've gotten so used to by just popping into the store whenever we wanted, COVID hits and suddenly we're not allowed to go shopping anymore. So they had to change their operation. They could, of course, not stop their retail business at all. They had to adopt to the new channels. Now, companies like Amazon and other companies have already proven that digital sales channels work and e-commerce works. So all these other companies who were generally in the big box retailer types where they preferred brick and mortar stores, they had no other choice but to resort to digital sales channels. And as more companies jumped into the competition, the more there was a need for bigger initiatives to take place so that they don't get overshadowed by someone who's doing it faster than them. So in large companies where things were more analog, where digital sales channel were not much of a priority, it actually pushed them to adopt these technologies much quicker than ever before, because before, if they had other priorities, now their only priority was to make sure that they kept on making sales and not be stopped by the regulations of the pandemic. Even more surprising about the responses from the survey was the rate of change the companies had undergone due to COVID-19 related effects. Between 12 potential changes in the respondents' organizations and industries, the survey shows that the companies or industries have acted 20 to 25 times faster than expected, as contrasted to what they had possibly thought before the pandemic. In terms of days, the expected number of days to shift to a remote working structure was around 450 days, and that was predicted before the pandemic, while in actuality, it took an average of 11 days to implement a workable solution, and nearly all the companies in the survey had remote working structures in place within a few months. As for the increase in advanced technologies that are used in business decision-making as well as operations, the average expected time frame of over 600 days was implemented in an average of 25 days. And this trend is seen across the different initiatives that were expected to take a long time to be implemented. But what we're seeing now is that these digital initiatives are being highly accelerated in order to utilize the business value or the value of business data better and optimize business operations and mitigate risks. I'd highly recommend you to go through the report from McKinsey and see the data for yourself in order to understand how COVID-19 has accelerated digital transformation in the industry. So I'll just put the link in the chat and feel free to take a look at it. And also, see, I have a few questions. Do we also need to know some complied languages?
Yeah, I would say so machine learning engineer or data engineer maybe needs some, but it's let's say maybe machine learning engineer need have more chance to use compiled programming, but for data engineer, I would say maybe higher level data engineer need a compiled language, let's say Scala, but for Scala, equivalence is Python, so we can use Python to do the same thing as Scala. So recently, uh, there is a trend, more and more people use uh, Python, PySpark instead of a Scala to run Spark. So the Scala mainly focus on the big data. Okay, so if the company have no requirements on big data, usually they use Python. Okay.
Thank you very much, Eric. Okay. We actually have another question regarding business and data analytics. The courses in WeCloudData support the students and hints to get their first job in the data field. I mean, you help us in the construction of our first portfolio for those who have not prior experience in the field is like our cover letter to wow recruiters and believe in us. If I understand your point correctly, yes. We will speak a bit about the program at the end, but let's pick it up at the end of the session, okay? But to answer your question, the business intelligence program, what we basically do is we have 8 different industry use cases and 5 different tools. So we'll take you through those 8 different industry use cases with those 5 different tools and help build up your intuition in solving different kinds of data analytics processes and different kinds of use cases. And as you work through those different projects, you also have 8 different projects on your portfolio, which basically helps to convince hiring managers that you are the right person for the job, because even though you don't have the experience with it, you have the right skills to be able to analyze any sort of data set. But I will explain more about that at the end of the session. Okay. So let's take a look at what's happening in the job market nowadays. Recently, things have changed a bit, but let's take a look at what happened first. As digital transformation explodes throughout the industry, so does the need of data professionals who are able to navigate the domain with expertise and creativity. This phenomenon has actually led to a new constraint in the industry, tech worker shortage. According to a Gartner study, IT executives see talent shortages as the most significant adoption barrier to 64% of the new technologies that are being implemented in their industries in 2021, in contrast to just 4% in 2020. This issue or this constraint has actually also led to a massive jump in salaries across the board for tech workers. So if companies before, when they were not trying to implement as many digital initiatives, the demand itself for the tech workers were low. Maybe they were hiring more for other business processes. But as soon as COVID hit and everything became more digital, suddenly the need for digital workers also exploded. So all these different companies, they were in a huge flurry to attract the high top talent from around the world. And that basically also increased the demand for these roles in the market, which basically meant the salaries also improved. The accelerated pace at which companies are adopting digital transformation is only being fueled by the proven success of the endeavor. And more companies are increasingly adopting data technologies when they haven't even considered it a priority before during the pre-pandemic era. From a state where analytics was only considered as a support department for many companies, business leaders were forced by the consequences of the pandemic to radically rethink old ways of working. And in most cases, they have led to organizations actually kickstarting the digital transformation, which in turn has led to more generation and storage of business data that could be used to better formulate informed strategies from business facts. Okay, so now that I hope that everyone has a good idea of what the data career entails and what are some of the roles out there and what are some of the skills that you would need to succeed in these roles, let's take a look at what are some of the options that are out there for you to be able to enter this field or to start off in this field. Now, there are many different paths of it in education that you can take nowadays. Before, it used to be more linear, where you would go to university, you would go to master's school, and that's pretty much it. But with the advent of the internet and the free use of the freely availability of internet for public, there are many more options that you can choose from now. Things like master's program, which already existed from before, but newer options like MOOCs, which are basically massively open online courses, things like Udemy, Coursera, LinkedIn Learning. Then you also have continuing education options. Usually universities would offer them, like larger universities with prerequisite programs, or boot camps like us. So let's take a look at the master's course option. This option usually has the highest admission criteria, as most universities require a mix of prior experience and a relevant undergraduate degree for prospective students. Now, that's not always the case, of course, but most of the master's courses that are out there, they will definitely require either a mix of these or at least one of this. The duration of the master's course is usually around 1 to 2 years, and mostly it emphasizes on theoretical knowledge and cultivating research skills. Unless you're opting for an applied sciences university, most master's programs are academic in nature and focus more on research-based learning rather than from a professional standpoint. For those who are not in a rush to land a job and are able to afford to do so, a master's program is always a good option since graduates are favored by big tech companies due to their involvement in research efforts. So the one aspect I would like to highlight about this is that if you like studying and if you like going into more of a research or academic field, then master's course option would definitely be your choice. Next up, we have the MOOCs, or the massively open online courses. Now, this option has been on the rise since the internet has become more accessible, as I've mentioned before. MOOCs are actually a great option for those individuals who are looking to enter the data field without breaking their bank or having the prerequisites. And this option usually has the lowest admission criteria out of the 4 options. The duration of MOOCs are usually shorter than the other options and are self-paced. So with the recorded videos or materials that are available for you to download at any time you want. It would generally take a longer amount of time for someone trying to enter the job market by just relying on MOOCs, because it does not enforce the academic rigor to motivate students, and the completion rates are usually very low. Since MOOCs are cheap and easily accessible, it is actually a very great way to begin with to prepare for a more formal type of education, since MOOC certifications don't imply much value to employers by themselves. Next, we have the continuing education option. So continuing education options are usually part of educational institutions that already have existing undergraduate or graduate programs that lead up to these programs. So whenever you consider any of the traditional universities, they would usually have continuing education option now. This option is usually favored by full-time work professionals who are looking to upskill themselves in addition to their prior experience. These programs cover practical skills that are more tailored to the job market demands, and the duration is shorter than a master's program, but longer than boot camps or MOOCs. Most continuing education programs are cheaper than master programs, and some are cheaper than boot camps. The certificates or diploma credentials that are earned at this program give the student an edge in the job market and provide more credibility than a MOOC certificate. With this option, students usually aim to complete their goal within a period of 1 to 3 years. In contrast to the other options, bootcamp programs are more focused on upskilling within a short period of time and help land jobs. They are usually favored by full-time job seekers and recent graduates. Since the demographic of the prospects are usually those who have a strong sense of urgency to land a job, bootcamps cater by providing shorter but more intensive courses as compared to the other options that gear students to getting job ready within a short period of time. The application process itself is much easier as compared to a master's program, and the admission criteria is lower as well. boot camps also usually offer better learning and career support with more personal assistance. Since bootcamp structure can vary between different providers, not all employers favor bootcamp graduates, but when it comes to applicable skills, bootcamp graduates are usually the best equipped out of the four options. This is why the general hiring consensus nowadays for data and technology roles are positively favoring bootcamp graduates over other options more than ever before. And I can personally testify to that because a few of my friends who work in different hiring roles, they're increasingly starting to look at bootcamp graduates rather than university graduates, just because of the technical expertise difference that they have coming out of each of these two options. And finally, here's an overall comparison of the various different types of programs. Like I mentioned before, each of them have their own strengths and weaknesses, and ultimately the choice you decide depends on your priorities. For example, if you're in pursuit of higher education and can devote 1 or 2 years on it, a master's program would definitely be a good fit for you. On the other hand, if you're interested in dipping your toes into the field or just upskilling, MOOCs and continuing education is great for that. If you want to focus more on learning the hands-on skills and need to get a job soon, then bootcamps may be good for you. Finally, we come onto the tips and resources section. So in this section, we just like to tell you about a few options that are out there for you to get started. And some of these options are actually MOOCs, which are freely available online. And I will just post the links here in the chat. So one of the first ways that you can start to explore whether you would be a good fit for the data career industry or the data industry in general is, first of all, understand and explore how data is being used by different industries. One of the best things about data itself is that the skills that you'll be picking up in either of these, it's any of these fields, it's actually very transferable across different industries. So if you're learning how to be a data engineer or a data scientist or machine learning engineer, there are high chances that 80% of your work will translate onto a very different industry, even though the data set is different. The other thing that you'd also have to do also is to understand and assess the importance and impact of data in the digital world. Now, after the pandemic, it has become very clear on how important data is in order to manage crisis and events that we may not be able to foresee. A lot of the projections that were done for COVID and related to deaths and the hospitalizations, it was done with data analytics and business intelligence and data science and data engineers. So if that is not enough of a convincing factor, you could always definitely take a look at what's out there and see how data is being used. Try to also see how your existing knowledge and skills can be augmented with data skills. Now, there's a lot of talk about computers replacing human jobs and all that, but computers don't automatically replace human jobs. It's only those people who have upskilled themselves with with their existing experience, along with the new data skills, that will be able to do so. So again, computers not going to come and take a job. It's just someone who knows how to deal with data and knows how to deal with computers who's going to take the job. And understanding how your previous experience can be augmented with data can definitely be your next step in career. The other thing you could try is exploring different roles and career opportunities that are there in data. So for example, an easy way that I would always recommend to the students is just do a quick Google search, type in the words analytics or data engineer or data science or data scientist, and see what are the jobs that are out there. Once you take a look at a few job descriptions out there, you'll be able to understand what are some of the types of companies that are hiring out there, and what are some of the skills that you would be needing towards a job description that interests you. You could also try to find out how different machine learning algorithms or artificial intelligence techniques can enable processes that were previously considered to be impossible. So this step is honestly for you to incite an interest in yourself for data and what is the potential of data. Nowadays, a lot of the cancer research and biopharmaceutical industries, they're actually using artificial intelligence to do medicine testing to see what kind of protein synthesis would work out instead of having to manually try them out. So they're basically using artificial intelligence to model if medicine would work on you or how it would interact with your body. So there's actually a lot of different applications out there. And some of the applications out there, if you read into it, you would honestly think that we are actually stepping into the future that movies have prepared us for in the 90s and 2000s. And yeah, so we've also posted some of the links down in the chat, which you can pick up your skills from. So things like SQL, W3 Schools is always a good place to start. And Mode also has a very structured way of introducing to SQL. For Python, W3 Schools, again, it's a very good reference book. And also this GitHub link, which is Jake VDP. You could always take a look at that if you want to pick up Python from a data science standpoint. For statistics, you could always take a look at Statistics by Jim, which is a blog post, or the YouTube page for StatQuest with Josh Starmer. If you are interested in looking for different data sets to work with, and you've already picked up the skills in SQL and Python and the other data skills, you could always take a look at Kaggle, amongst many others that are out there for a different bunch of data sets. Kaggle also periodically hosts competitions. So if you're confident in your data skills, you could either go at it alone or join up with a team to attempt at competitions that are hosted by different organizations and companies. And it usually involves monetary compensation as well. If you're looking to learn from Kaggle, then there's always the option of that. So you can also search up www.kaggle.com/learn. And if you are more interested in the creative aspect or the design aspect of visualization or the business intelligence part, you could always take a look at makeovermonday.co.uk. And it's basically a website that people upload their visualization designs to, and you could always take a look at what some of the other people are doing with different data sets that are out there. For data engineering, there's always the YouTube channel, Seattle Data Guy, and watching his videos, you'll definitely be able to pick up the nuances of data engineering and how to get started with it and how to evolve in this field. And that brings us to the end of the session today. I hope the session has been insightful for everyone. And if you still have any questions, I will stay behind along with Eric for the next 20 minutes. And if you have any questions about our programs itself, you could always email at us at info@WeCloudData.com. So Eric, do you want to say some last words?
Yeah, I see some questions. Can you answer this? Are there any requirements about the continuous education route? Do you know this?
So, okay. So do you need to have a data focused degree or be in a data business job to do the continuing education route? It depends on university to university. For example, as far as I know, UFT, you would have to check their website. I'm not too sure about the exact specification for the requirements for these continuous education routes, but generally they would require you to have some sort of undergraduate degree. I'm not too sure if they need a relevant one, but you could always check out with the providers and see what they provide. So for example, UFT, Ryerson, TMU, all the other universities out there who have continuing education, you should definitely check in with them. And we also have another question. What do we think of the Google Data Certificate? So Google Data Certificate falls under the MOOC option. It's definitely a good way for you to get started, but from my personal opinion, Google Data Certificate is not enough for you to succeed as a data analyst or business intelligence professional, just because only knowing how to clean data or how to visualize data is not enough. It has to be with relevant business context. So if you're presented with a data set, how do you first understand that what are some of the important aspects that you should be taking a look at it? And only then you'll be able to formulate the questions that help you progress towards the analysis and the final end result. Okay, so we are jumping back to Marcus' question.
Yeah, so and then so before you answer this question, I want to give one more about how you feel, is that enough or not? So it's very simple actually, so let's say, I already mentioned that, there are several roles in data field, right? So data science, data engineer, data analysis, data architects, and maybe this is a bit further. So, and also machine learning engineer. So you just type this kind of keywords into, let's say LinkedIn. They will pump up many, data related jobs. So you can read the job description, you will understand so what type of skills you have and what type of skills you don't have, and you can accordingly to get the skills you don't have to meet their requirements. Okay, thank you.
Yes, I totally agree with Eric. That's actually one of the quickest way that you could do that. If you already know what kind of industry you'd like to enter and you are studying Google Data Analytics with that goal, then you should be taking a look at the goal itself and see what else they require if data analytics, if the Google Data Analytics is not enough. So if you're generally joining entry-level roles, Google Data Analytics would work only if you're working with a large company that has a role that allows you to work with only specific data set. But then again, most companies wouldn't hire a whole role for that or a whole position for that. They would need you to have other expertise as well. So again, as Eric said, please compare it with the job description that is out there that you're interested in and see what's missing out of what's being provided in the Google Data Analytics certification.
Sorry, can I just jump in instead of typing it all?
Of course, go ahead.
So you guys are saying more so that like the Google Data Analytics, because I know it's like it's R, it's not Python, like things like that. Like it's very basic, you're saying? Like, is it almost worth the time, or should, like, as far as self-learning goes, like, should you kind of like just go about the route of learning the individual pieces as opposed to getting something that says like, oh, you're certified in this, where it's not really, is just focusing on MOOCs as far as like I'm already employed and like looking to just transition, things like that.
Okay. So the point of studying would not be to get the certification, because the certification is just a piece of paper.
Exactly.
In the
So,
end, what's
like
more,
we're saying,
sorry.
like the skills that are required from that certification are like very, very, very basic. You're saying, as far as just like that, it's basically an intro where it's like it's almost like 6 months. It's saying that's like 6 months of studying. So you're saying there's like much better, quicker ways to go about it almost?
Well, okay. Depends on what your situation is, right? If you're able to, like, let's say, opt for like paid options, then definitely there are better options, in my opinion, right? Google Data Analytics certification, it's a very good MOOC option because first of all, it's for free. And if you've never experienced data analytics before or data field before, then it's a very good option for you to do so. Because first of all, it's free. If you have no idea whether you're actually going to enjoy it or not, these 6 months are going to be a good opportunity for you to understand that whether you actually enjoyed it in the first place or not. And it's not as if it's very basic. As far as I've seen, the data analytics certification actually teaches you good stuff. But in my opinion, is it enough for most jobs? I don't think so. Maybe I'm coming in from a biased standpoint, but that's just my personal opinion. I hope that helps. Or did I miss the question?
Oh, no, sorry. Yeah, that was perfect. Thank you.
Okay, not a problem. So again, like if you've never been in the data field before, trying out a MOOC course is definitely one way to understand whether you'll actually like the field or not. So for example, when someone finds the data field, right, it's most likely that they have heard about it from one of their friends, coworkers, or maybe online, where it speaks about like, data science is like biggest thing out there right now. And people jump into it, right? Definitely that's one of the first steps. The curiosity is the first step, but also exercising or exercising effort on your curiosity definitely is the next step. That whether you are actually interested in this because you have the passion for it, or whether it's just due to hype. So MOOCs are generally a good filter for that. That first of all, if they're free, then dipping your toes into this field, MOOCs would definitely be a good option. And Google Data Analytics provides that.
Is there one like alternatively that is like still structured and gives you like a course as opposed to just like YouTube videos and like just playing around in the programs like that you'd suggest other than that one? Because I know there's other ones like IBM and things like that.
Yeah, exactly. Like IBM, Coursera, Udemy, LinkedIn Learning, all those different online courses that are like pre-recorded, you can consider them as MOOC. And the point is that these give you a good idea of what the roles entail, but it doesn't get you job ready because job requires much more usually.
Awesome. Thank you so much.
No problem.
Also, are we getting like can we get like a recording of this just because I missed like the first like half hour?
Yes, of course. You'll be emailed with the recording link after the session. It'll just take a while because the recording takes a while to process. Okay.
Awesome. Thank you guys so much for your time on here.
No problem. All right. So I see Marco's question regarding business data analytics, the courses in. Okay, so it's the question as before. So for the business intelligence program in specific, what we try to focus on is the real industry use cases. So for example, you have the data skills or you have the skill sets that are necessary to wrangle all this data, but to what end? To answer what questions? So the whole BI program is structured around that we're helping you solve end-to-end, eight end-to-end projects in different industries using the 5 tools, which is Excel, Power BI, SQL, Tableau, and Python. Now, these industries can range from supply chain, healthcare, sorry, not healthcare, supply chain, finance, open government data, retail, and marketing analytics, amongst the others. So for more details, you'll have to take a look at our website and you'll see what are the different syllabus that's covered. Okay, so following the, sorry, I do have a question before that. Can you advise if I should go with the DA or BI course? I am interested in a role where I can get to analyze data for taking business decisions. So DA and BI is technically the same thing in the end. DA stands for data analytics, BI stands for business intelligence. If there is one difference I had to point out between them is that data analytics, it's more to do with analyzing the data only, where you're using all these tools to find insights out of this data, while business intelligence would be doing the exact same thing, but also cater towards the business units itself. So you're basically using the data or analyzing the data to provide business answers. Now, the roles themselves, they're technically almost the same. It's just that the titles are somewhat different. Business intelligence, it sort of deals more with the business units. Data analysts, they focus purely on the data more. But then again, that's not a given thing. Job titles can sometimes be misleading. So reading the job description is your best bet to understanding whether a role is actually business oriented as well, or just data oriented.
Yeah, another question about LeetCode.
So,
yeah, of course.
Following
Yeah. Sorry. So about the LeetCode. So the LeetCode actually is very useful to land a job. Okay, not only LeetCode but HackerRank. Okay, so both LeetCode and HackerRank are very useful. Even some company they collaborate with LeetCode or HackerRank. Especially for data science or data engineer. So when you have an interview, some company just throw you a link. This link may be a LeetCode link. Okay, they give you some a quiz in Python SQL. So ask you to finish within 1 hour or half an hour, depends on their requirements. Okay, so definitely, if you get used to this kind of thing, you have two privileges. The first thing, you get very familiar with the SQL and Python. The second thing is get familiar with this platform because different platform they have their style. The first time if you go to this platform, you got very confusing. Even you spend most of the time when you're having an interview to figure out how to use this platform. That won't be a very good situation, right? So LeetCode and get used to LeetCode and HackerRank. That will be very useful. Okay, that's for this question. Thank you, Adam.
Thank you, Eric. So we also have another question. Following the Google Data Certificate question, I am at the point where I need the relevant business knowledge or understanding of the business context. I feel like that is what is missing from my portfolio. Demonstration of statistics, applications maybe, or convincing business acumen. I had no previous relevant knowledge degree, but I have completed data analytics bootcamp, UT, University of Toronto, I assume, and online data certificates like Google and IBM. What should my next step be? And can you guys help? Okay. So it seems that so you've studied data analytics bootcamp at UFT and online data certificates. So your technical skills are definitely in place, it seems like, if you've successfully completed the boot camps and the data analytics certificate. But what you need right now is a good portfolio, that you basically have a portfolio where your hiring managers can go into and take a look at what work you've done. Now, your portfolio cannot be as simple as something like, oh, I am going to just visualize what is the sales per month on a chart. It has to be specific towards solving business problems that are out there. That, okay, there is a messy data set and the finance department wants to know certain KPIs out of it or understand certain metrics out of it, right? What are some of the steps that you took in understanding what the finance department needs? And how did you manage to source the data? How did you clean the data? What did you do with the data in the end with the data modeling? And what was the initial, like, final dashboard like? And finally, does it serve the purpose of what the finance department was looking for in the first place? Now, when you say relevant business knowledge or understanding business context, right? It's hard. It's the chicken and egg race again, where you cannot know about it until you work with it. But to work with it, you need to know about it, right? Certain things like understanding how a general business functions. Like, okay, if it's a medicine company, what are some of the aspects of the medicine company stakeholder? Like, what would a medicine company stakeholder care about, right? Probably about production levels, or maybe about sales, or maybe about outreach, right? Let's say that you are interested more in the marketing department or the data analysis for marketing department. So you're going to have to see what are some of the marketing channels or marketing options that pharmaceutical companies use these days. Maybe digital marketing, digital ads. I honestly have not read a newspaper in a very long time, so I don't know if they exist. Social media posts or something like that, right? Then that's when you start building your business context that, okay, if I was a stakeholder, or if I was a business stakeholder in this pharmaceutical company, what are some of the data insights that I'd like to see from the existing data sets? And you start answering your own questions by building a project that allows you to delve into the data to easily answer those questions. And that one project gets on added to your element as an element to your portfolio. And that is something that we also do during the boot camps itself, that we help you train on specific industry use cases like this, that, okay, you have been presented with a problem. How are you going to use your existing knowledge plus the knowledge that you're going to pick up during the school itself to be able to solve these industry problems? And can we help? We definitely believe we can. So please take a look at our website, take a look at the different programs that are out there and the ones that we've talked about. And if you have any questions, feel free to reach out to any of us at any time. There's also a form on the website. You can use that to submit a request, or you could add either me or Eric on LinkedIn. I'll just put this back up here. And you could always ask us the questions. So I think data analytics can pass for a junior position. Okay. Google Data Analytics is not impressive for recruiters. Yes, I've heard that before as well, where I've talked to a few recruiters and I've asked them, like, what do you prefer more? Right now, the consensus is that, oh, as long as you're from a large university, out of a good university, then you have higher chances. But before it was that that was the only option, but now boot camps are also going into that phase, which is good. But MOOCs and MOOCs are generally not considered enough, as far as I know. If I like to change the field I'm working on, like from finance to healthcare, currently data analyst, what is your advice to get that opportunity and no experience in healthcare industry? Okay, since you already have the expertise as a data analyst, the best thing about being a data analyst or being a data professional is that you just need to be able to work with a different data set. So try to get a few data sets from Kaggle. Kaggle usually has the COVID predictions, the diabetes prediction, and a bunch of other healthcare data sets, and do some analysis on it by yourself. If you have no idea what to analyze, try to see what kind of other analysis that other people have done on Kaggle itself. You can take a look at what other people have done on specific data sets. And that will give you an idea of what are some of the metrics that a healthcare professional would be interested in. If Kaggle does not provide you the answers, then Google's your best bet. Try to Google the keywords healthcare analytics or healthcare analytics uses and see how healthcare is using analytics. And you're basically trying to use that context that you're picking up from Google and applying it to the use case or the data set that you're getting from Kaggle to answer those business specific questions. And once you complete a project like that, try to make the design a bit nice so that it's easily accessible for viewers and upload it to your portfolio. Portfolio is the best cover letter for those with no prior experience. I definitely agree. Okay. And thank you very much for the resource, Kevin. That is definitely a good program as well. Health informatics, I think even some of the other bootcamps have healthcare specific ones. But again, if you already have the experience working with data, all you'll have to do is just switch your data set and understand what are some of the business requirements that that industry has. So that's one of the best things about IT, software and data in general, that as long as you know how to work with computers and do the specific requirements that are needed for you for the role, the industry doesn't matter. Is data scientist hired in the science field, like in physics? Definitely. I'm not sure if you guys have seen the first image of a black hole that was kind of popular a few days back with the new James Webb telescope. So that image itself, it's not exactly, if you looked into the sky at the black hole, that's not what you would see. What that image was created out of was that they took multiple readings, the radio frequency readings of the black hole, and used algorithms like artificial intelligence algorithms and data science algorithms to composite all those radio frequencies together into one image, and then applied false coloring on it to make it seem like, okay, this is what it would look like if you were actually looking on it. And that's the same thing with the James Webb Telescope new photos that came out of the constellations and nebulas. If you take a look at these structures in space, you would not be able to see all this light. It's all light that cannot be detected by human eyes. It's all radio frequencies. But if you were to convert these radio frequency waves into something that is visible within the visible light spectrum, then this is how it would look like. And that's what data scientists help you do.
Yeah, and another story is, last 2 years ago, I talked with a hire manager from a pharmacy industry. So that's a very top level pharmacy industry. And but their company size not very big, so it's just more than a startup. So the hire manager told me, actually it's a director. So he told me, there is many, scientists in this company, but they don't know how to use data. Okay, so that's why they are going to build a data platform to organize data and make the data more usable for these scientists to make a data analysis and data science. So that's can be a evidence to show that the data science was used for a science in the field. Yeah.
Yep, I totally agree. So if you consider what a physicist does, right, they would basically generally be responsible for taking measurements of the physical world or the physical aspects of nature and building understanding or models about it, right? And the general consensus of any experiment is that the more sample data that you have, the higher frequency of number of observations that you have, the more accurate your sampling rate is going to be. So if you are manually able to process, like, say, 10 records of data, then why not train a computer to do 1 billion records, right? The more records that you have, the more accurate your predictions become, and the more accurate your models become. So for a physicist, data science is actually one of the most important tools in the industry right now. And if you take a look at what NVIDIA is doing with their flow simulation, with their new graphics card, physicists are actually using that to predict, how earthquakes, no, that's actually not the job of physicists, but basically geological scientists are using to understand how earthquakes can occur at different points of the world and what are some of the outcomes that could happen because of those earthquakes. Now, just because there are so many variables that can happen with earthquakes, things that can change, basically, you'd need to be able to compute all those different events easily. And that's what graphics like GPUs help you do in the end, like, data science models and like artificial intelligence and machine learning models help you do. They basically help you take a huge amount of data and make sense out of it. I assume a DS in physics needs a PhD. Not necessarily, because, sorry, Eric, do you want to take this?
Yeah, actually, it's not necessary because you are doing data, right? So you're not doing, although you are doing, you are in the physics in field, but you are mostly the objects you are working on for is data, right? So you need their requirements. You need their, so what's the mechanism behind their requirements, and what's the terminology? As long as you know this, and you use your data way to meet their requirements. So that's what data scientists do. So it's unnecessary to must be a PhD in physics or in mathematics. It's not appropriate, right? So, and there is no data scientist PhD degree, right? So and also we have in our alumni we have one student who is working in geological industry, geological as a geology scientist, data science, because previously he graduates from geological background in a university, and then he finished his data science boot camp, and he landed a job in a geological company focus on the research on kind of like earthquake or something, to do data analysis something, and do data science. Yes.
I hope that answers the question. And also one thing about PhD is that when you say that, like, if DS in physics would need a PhD, right? It's more about the question of what state that physics domain of knowledge is in. If it's in something that's still in the experimental phase, that is still being, like, researched upon, then probably yes, you would need PhD. But if it's something that's already been proven as a fact and, like, people are already working on it, then you would not need a PhD. And I'm assuming that your question was relevant to PhD in physics, not PhD in data science. Yeah. So again, like, if you're working with something that has been proven already, some sort of physical law that has been proven, then you would probably not need a PhD degree to understand more about it, because a PhD degree is more about the research aspect of it. But let's say you're trying to build up a new super, like, string theory or something, then probably you would need a physics PhD. Sounds good. Okay, did we miss out any other question? All right, so it is 9:07. Do we have any further questions? Okay, so if any further question, feel free to reach out to our advisors at info@WeCloudData.com. Feel free to also add me and Eric on LinkedIn, and we'd be happy to have a chat with you. And please do visit our website at WeCloudData.com to see what our option of studies would be and how we can help you on your career journey. So I'd like to thank everyone again, and I'd like to thank Eric as well for joining us today. And I hope you all have a lovely evening ahead, and hoping to see you in the next session. Take care.
Take care. Have a good night.